Here, let's before we talk about the example, let's briefly mention about a binomial distribution and how it's obtained from a probability experiment called a binomial experiment. And here the experiment must satisfy several conditions. Here the first one, each trial can have two outcomes. The outcomes are either a success or a failure. Second condition, there is a fixed number of trials. 3, the outcomes are independent of each other. In other words, one does not depend on the other events, outcomes. And then fourth, the probability of success remains the same for each trial. Now we're going to go through an example. Here's an example of a binomial distribution, and this is entitled Win or Lose. Here the Hawks are currently winning 55% of their games, and there are 5 games in the next few weeks. What we want to find is the probability that they will win more games than they lose. So here there are 5 games left, and we want to see that they win more games than they lose. So that they have to win at least 3 or more games. So 3, 4, and 5 games. So what we're going to have here is the probability that they're going to win 3 games, the probability that they're going to win 4 games, and the probability that they're going to win 5 games. And remember, this is sort of combination. They could win their first 3 games, or they can win their last 3 games, or in between. So here we're going to write the probability for this is example of a binomial distribution. Probability of x is equal to 5 over x, and this represents the number of combinations of winning 3 in the next 5 games. So they win 55% of their games. That's x, and then right here it's 0.45, so that represents the losing. So that would be 5 minus x. Again, this 5x notation represents the number of combinations, and this represents 5 factorial over x factorial over 5 minus x factorial. Okay, so for example, 5 factorial means 5 times 4 times 3 times 2 times 1. Okay? So here, what we have is probability of winning 3 games is equal to number of combinations of 5 factorial over 3 factorial, because this is winning 3 games, and then this is 5 minus 3 is equal to 2 factorial, 0.55 times 3, raised to the 3rd power, 0.45, and 5 minus 3 is squared. So one way to check is making sure that the number of events winning and the number of events losing is the total number of games, in this case 5. Alright, probability of winning 4 in this answer is equal to 0.337. Now we need to calculate the probability of 4 and the probability of 5. So the probability of 4, following a similar process, will be 5 factorial again, 4 factorial, and 1 factorial, 0.55 raised to the 4th power, that's the number of wins, times 0.45 raised to the 1st power, and this evaluates to 0.206. So now we have the probability of winning 3 games in the next 5, the probability of 4 in winning the next 5, and then the probability of winning all 5 is equal to 5 factorial over 5 factorial and 0 factorial. And 0 factorial is just 1. So it's 0.55 raised to the 5th power, winning 5 games, and 0.45 raised to the 0 power, which is just 1. So when you evaluate this, it's 0.50. Now the probability of winning 3 or more games, probability of winning 3 or more games is equal to all these probabilities, 0.337 plus 0.206 plus 0.050, and that yields 0.593. In other words, the probability that the Hawks will win 3 in the next 5 games, winning 3 or more games, is 0.593, or 59.3%.